This final chapter, Chapter 6, contains 6 quiz questions to test your understanding of the materials covered in this module. Question 1. Assume that 3-month LIBOR spot is 2.5% and that each forward after that lies 10 basis points higher. And finally, that all other market conditions are as indicated in worksheet pricing grid. You are asked to analyze the following term sheet and to solve for the value of X in the coupon formula below, assuming no profit margin for the dealer. When valuing any interest rate swaps, you may discount future cash flows at one single blended rate rather than at individual discount rates. Here's the term sheet. Note the X in the coupon formula, X% minus LIBOR. And here are your 4 permissible answers. This worksheet question 1 solution contains a single grid in the top left which prices caplets with different maturities based on the 2.5% LIBOR spot and the 10 basis point increase in each forward rate after that. We do not need floor prices for this question, nor do we need the remaining grids that used to appear below this first grid as in previous versions of this worksheet. The one thing you also should note that appears further to the right in this worksheet is the summary of prices for caps as well as the swap rates in row 7, and please note in particular the 5-year swap rate of 3.42% in this cell S7. The diagram appearing now shows the investor purchasing a 5-year fixed rate note from the issuer with a coupon equal to the swap rate of 3.42, and then also entering with the issuer into a 5-year receive fixed interest rate swap, whose fixed leg we do not know just yet. So we will set it to be F as in franc %, where F is less than the 3.42 market rate. The fact that F is below the market rate makes the swap's NPV negative for the investor and positive for the issuer, in return for which the issuer will give the investor the necessary option that guarantees the minimum 0 coupon. The total coupon the investor is receiving in aggregate thus far is 3.42 plus F minus LIBOR under the swap. So he needs a cap on LIBOR with strike X% to prevent his coupons dropping below 0. This allows us to set 3.42 plus F minus X equals 0, and therefore F equals X minus 3.42. So the fair value of the IRS is the PV of an annuity of 20 quarterly cash flows, discounted at the swap rate of 3.42 and each of size X minus 3.42 minus 3.42, which is X minus twice the 3.42. And this value must equal the premium for the cap. With this background in mind, we return to our worksheet and take note of the following inputs and formulas. First, in the cell L5, the entry for the cap strike, currently set deliberately very far from the likely answer at 10%. Lower down, in cell KL10, the formula for the swap's fixed leg, obtained simply as the cap strike minus the 342. We established that earlier. 4 cells underneath, the PV of the swap, calculated simply as the PV of the annuity as discussed a minute ago, representing the difference between the off-market swap rate and the correct market swap rate. And this is from the perspective of the investor, we remind you. Next, in K18, 4 more cells further down, the premium for the cap, appropriately multiplied by the notional of $100 million, and therefore expressed in absolute dollar terms. And last, but perhaps most important, in cell K22, the sum of the 2 PVs for the swap and for the cap, currently adding up to a negative $14.6 million. And we know that those must sum to 0 when we have a correctly priced transaction. So now we use goal seek, and we set cell K22 equal to 0 by changing, of course, the strike in L5, and we hit OK, and there revealed to us is the strike of the cap of 670, which is of course also the value of X in the term sheet. Therefore, the correct answer to this question is C as in Charles. To complete the analysis, you will note that the fixed leg on the swap comes to 670 minus 342, which is 328. And so the swap is off market by some 14 basis points. We should mention at this point that this type of instrument, and generally any instrument whose coupon takes the form A% minus LIBOR, is called an inverse floater, and is often of interest to those who expect rates to fall beyond what the curve may be pricing in already. The more aggressive investors have even been tempted at times with coupon formulas such as 25% minus 4 times LIBOR, which gives a much larger bang for the buck when rates drop, but rapidly devastates the coupon when rates rise. These types of instruments are sometimes called leveraged inverse floaters. The next quiz question will focus on a very important property of inverse floaters. Question 2. Assume below that line A represents the price-yield graph of a fixed-rate note, and line B represents the price-yield graph of a regular FRN, ignoring convexity and short-term rate fluctuations. Which of the 4 alternatives for line C would most accurately represent the price-yield graph of the inverse floater described in the preceding question? Here are the 4 alternatives. Solution to question 2. We know we constructed the instrument in the previous question by purchasing a 5-year fixed-rate bond and entering a swap in which we receive fixed as well. The first component, i.e. the 5-year bond, would have a modified duration of around 4.5 or so, and the swap would have a similar, in fact slightly lower, modified duration. Therefore, the inverse floater, being essentially the sum of these two components, should have a modified duration almost twice that of the regular fixed-rate bond. And therefore, its price-yield graph should be also inverted, like a fixed-rate bond, but steeper than that of a regular fixed-rate bond. So the correct answer is D, as in David. Question 3. Using the LIBOR curve and other information contained in worksheet Pricing Grid, calculate the approximate profit margin achieved by the arranger that structures the colored FRN described below. You should assume no subsidy was passed on to the issuer. Here is the term sheet. Note the 50 basis point spread over LIBOR, the minimum coupon of 2.5, and the maximum coupon of 7.5. And here are the 4 permissible answers. Solution to question 3. The min-max floater, as we saw earlier, is built out of an FRN plus a long floor and a short cap. The strike of the floor here is 2%, while that of the cap is 7%. On this worksheet, question 3, solution part 1, we now price these two options. And so we insert a strike here of 7%, hit enter, and go over to the grid summarizing the prices, and note through the link in the cell that the 7% 5-year cap is now revealed to cost 246 basis points, or more specifically to earn 246 basis points for the investor, while the bought floor, whose strike, you recall, is only 2%, that one will require a payment from the investor of a mere 6 basis points, as you can see here. The substantial steepness of the curve explains largely the enormous difference between these, and they net out to 240 basis points in favor of the investor. As we know, this premium is given to the investor in the form of the spread over LIBOR rather than upfront. So we now turn to this worksheet, question 3, solution 2, to value the 5-year annuity of 50 basis points paid in 4 quarterly installments annually, i.e. in installments of, as you can see here, 12.5 basis points per quarter, apparent from the term sheet. This cell E26 reveals the PV of this annuity using the LIBOR curve in column C and the discount factor stemming from that in column D to be, as you can see, just around a total of 225 basis points in value, which means the remaining 15 basis points out of the 240 must be the dealer's profit. We restate here in these 2 bullet points the results of our last 2 calculations, which led us to a dealer profit of 15 basis points. Therefore, the answer to this question is A as in apple. Question 4. Using the LIBOR curve and other information contained in worksheet pricing grid, calculate the approximate profit margin achieved by the arranger that structures the range floater described below. Assume no subsidy was passed on to the issuer. Here is the term sheet. And here are the 4 permissible answers. Solution to question 4. This worksheet question 4 solution contains pretty much a self-sufficient explanation for what is going on. The worksheet begins by pricing caplets at each strike from 5% down to 2% at 50 basis point intervals. And also, a little further to the right of the first set of caplets, other caplets at strikes exactly 1 basis point higher for each of these. Combining these into a long-short position enables us to price digital caplets. So, for example, a digital caplet struck at 5%, expiring in 2 years exactly, costs $700, as appears in this cell Z14. The digital caplet prices are summarized in this grid, which begins in column AB. Shaded in light blue are the digital caplets the investor purchases to reflect the lower boundary of the relevant range. So 2% for years 1 and 2, but 3% for year 3. Shaded in lilac are the digital caplets the investor sells to reflect the upper boundary of the relevant range. So 4% for year 1, 4.5% for year 2, and 5% for year 3. The bottom row contains the relevant totals for each digital caplet being bought or sold. The premia earned and paid are netted appropriately in the cell AF21, and the result is multiplied by 500 to reflect the payout under the structured note of 5% when the LIBOR reset falls within the range. Next, cell AF23 calculates the price of a 3-year zero coupon bond, which is of course how the investor's principal is guaranteed. And this is calculated simply as the $100 million face value of the bond times the discount factor hidden in cell G18. And finally, in cell AF24, right at the bottom of your screen, we subtract that plus the net caplet premia from 100 million to derive the arranger's profit. This turns out to be around
$1.31 million. So the correct answer to this question is B as in boy.
Question 5. Using the LIBOR curve and other information contained in worksheet pricing grid, calculate the value of X in the coupon formula for the super floater described below. Assume no subsidy was passed on to the issuer and no profit margin was achieved by the arranger. Here's the term sheet. Note the 3 times LIBOR minus X in the coupon formula. And here are the 4 permissible answers. Solution to question 5. We begin the analysis by noting that the coupon formula is presumably obtained by purchasing a floating rate note at LIBOR, then entering 2 swaps in which investor receives LIBOR and pays fixed at F%, where F is an off-market rate that gives the swaps a negative PV from the perspective of the investor, and therefore specifically F is above the market rate. This gives the investor so far an all-in yield of 3L minus 2F, simply combining these arrows. In return for paying this above market rate, the investor will acquire a floor on LIBOR that stops this all-in yield of 3L minus 2F from ever going negative. So the investor will acquire floors on a notional of $300 with strike K equals 2F over 3, from which it follows that F equals 3K over 2. The fair value of each IRS is the present value of an annuity of 20 quarterly cash flows discounted at the swap rate of 4.77 quarterly compounded, and each having a size equal to F minus 4.77 divided by 4. The aggregate value of the 2 interest rate swaps must equal the premium for the $300 floor. With this background in mind, we now turn to this final worksheet, question 5 solution, and take note of the following inputs and formulas. In cell L5, the entry for the floor's strike, set deliberately pretty far from the likely answer at 8% for now. 5 cells down, K10, the formula for each swap's fixed leg being 3 times the strike divided by 2, as we know. Then in cell K14, the formula for each swap's PV. From the perspective of the investor, we remind you. Next, 4 cells down, in cell K18, the premium for the floors using a notional of 300 million. And finally, but perhaps most importantly, in cell K22, the formula for the sum of the aggregate PV for the 2 swaps combined plus the premium for the floor. And we know that this quantity, this critical quantity, must sum to 0 for a correctly priced transaction. And so now we use goal seek and set this cell equal to 0 by changing the strike of the floor, and we hit OK, obtaining a strike of 3.6% for the floor. From this, it follows that the swap's fixed leg is 5.4%, so that the value of X in the coupon formula in the term sheet is 10.8%. So the correct answer to this question is D, as in David. Our final question, question 6. Please examine the term sheet below and identify the embedded derivatives from the issuer's perspective. Here's the skeleton. The coupon reads lower of 3-month LIBOR plus 50 basis points, or, remember, lower of 3 times LIBOR minus 9%, subject, of course, to a 0 minimum. And here are your 4 permissible answers. Solution to question 6. Setting the first and second parts of the coupon formula equal, we get L plus 50 basis points equals 3L minus 9, which leads to L is 4.75%. So we know the investor has bought an FRN and has sold either caps or floors at that level. And since under the formula the investor's pain increases the further LIBOR declines, it would appear the investor has sold floors, and in fact 2 floors, at this level of 475. The investor has also bought 3 floors at 3% to stop the expression 3L minus 9% from ever turning negative. So the correct answer is C, since the question is worded from the perspective of the issuer. Continuing with this instrument just for a moment, the net premium the investor has earned after paying out any fees and subsidies has been converted presumably into an annuity of 50 basis points per annum. The grid below summarizes the outcomes for the investor's coupon under each LIBOR reset scenario. Here we go. LIBOR resets at or below 3. The FRN pays LIBOR. Short 2 floors at 475. Payoff minus 2 because of being short. Strike minus LIBOR. Long 3 floors at 3. Payoff 3 times strike minus LIBOR. Annuity is a constant 50 basis points. Aggregating these together, I get 0. Scenario 2, LIBOR between the 2 strikes, FRN still at LIBOR. Short 2 floors still in the money. Long 3 floors now out of the money, so payoff is 0. Annuity doesn't change. Aggregate everything. 3L minus 9. Finally, L above the second strike of 475. FRN pays L. Floors expire worthless. Spread 50 basis points under the annuity. So LIBOR plus 50. And this confirms exactly the term sheet. For the sake of completeness, we conclude this quiz question by showing you the coupon graph for this instrument, shown here in red, set against the blue graph for a regular FRN, hopefully to assist your understanding. Note when the short floors at 4.5 come alive over here, the coupon begins to drop very quickly, and by the time LIBOR hits 3%, the coupon has gone to zero and remains there at all values of LIBOR below 3%, a risk the investor has taken in return for earning the 50 basis points in this area here between those two diagonals. This completes Chapter 6 as well as the entire module.